This is Algebra 2 with Trig, 9.1a, the first day that we're going to be talking about theoretical probability and defining probability. To start this off, we're going to have a warm-up, just working on our basic factoring. So reminding ourselves that we're looking for what multiplies to be 6, positive 6, and adds to be negative 5. So when we set up our parentheses, if we're using a guess and check method, the two things that would multiply to be x squared, of course, would be x and x. Then we're going to look for the two numbers that are going to multiply to be 6. And there's two sets of those. 1 and 6, 2 and 3 are the only ways that you can multiply to be 6. Now, if you look at these numbers, if you put positives or negatives near them, both of them can make 5 for the middle. So it gets a little confusing, and people get this one wrong a lot because they use the wrong signs in the wrong spots. But if we use negative 2 and negative 3, when we do our outer and inner of FOIL, we get negative 3 and negative 2. That gives us negative 5. And it would multiply to be a positive 6. So those would be the correct numbers. If we use 6 and 1 in this spot, you could use negative 6 and positive 1, and that would add to be negative 5. But when you multiplied it, you would not get a positive 6 with the numbers positive 1 and negative 6. So let's try this one. Remember, or notice, our leading coefficient is a 1. So it makes life a little bit easier. We can just put down our parentheses. We know our first two numbers are going to have to be x and x. And our last two numbers are going to have to multiply to be negative 6. And add to be negative 5. So if these are our factors that make 6, negative 6, positive 1, adds to be negative 5 and multiplies to be negative 6. So those are the basic steps that we want to take to factor a trinomial that starts with a leading coefficient of 1. Our learning targets for today, of course, are listed, and we're going to be working on theoretical probability. Experimental will be tomorrow. When we roll a standard 6-sided die, the possible results are called outcomes. So what are the outcomes for rolling a 6-sided die? You can get a 1, a 2, a 3, a 4, a 5, a 6 are the different results that we can get when we roll a die. An event is an outcome or a collection of outcomes. So for example, the event of rolling an odd number, we're looking for the outcomes that are the odd numbers. So 1, 3, and 5 would be considered our odd numbers. Those would be the event of rolling an odd number. When we talk about probability, it's the measurement of the likelihood or the chance that an event will occur. So our probability answers are always going to be between 0 and 1. So we're not going to use an answer that is 50%, 75%, no percentages, because those numbers will typically be larger than 1. We want answers between 0 and 1. So our answers are definitely going to be decimals. We can represent that as a fraction. And in some cases, we talk about it as a ratio. But notice we're not saying percent. As we list out the decimals, different answers that you can get from 0 to 1, 0.5 would be in the middle. Now, I say we don't write answers as 50%, but we'll probably explain things as a percentage. 0.5 would be you're halfway through it, the 50% spot. Anything less than 0.5 would be less likely to occur. Anything more than 0.5 would be more likely to occur. When we talk about theoretical probability, that's the mathematical probability. What do you get when you do the math? That's theoretical probability, the math side of the calculations. Not about how many times you rolled the die and got it to show a specific number, but mathematically, what should it be? So theoretical probability of an event. I like to think about probability not as much as the number of outcomes in event A over the total number of outcomes. Always seems a little confusing. I like to think about it as favorable over possible. So whenever you read a problem that says find the probability, you're always thinking of favorable over possible. You're always thinking of a fraction, and you're looking for the favorable way something can happen, the number of outcomes in an event, and the possible ways something can happen, which is the total number of outcomes. Okay, to start our probability out, we're going to talk about a deck of cards. Some of you may not be overly familiar with a deck of cards, so we have to talk about some of the details. All up here in the words spells it out, but I'll point to a lot of the details here. A deck of cards has 52 cards, and they're divided into 4 different suits. One of the suits is clubs, diamonds, hearts, and spades. Each suit has 13 cards. You can consider an ace to be a 1, and then there's a 2 and a 3 and a 4, 5, 6, 7, 8, 9, and 10. Then there's a jack, queen, and king for each suit. So there's 4 different aces, 4 different 2s, 4 different 3s, all the way up to 4 different jacks, 4 different queens, 4 different kings. The club card, they're always black, so they're the black cards. The diamonds are always red, so they're red cards. Hearts are also red, and then spades are considered black. So you have half the cards being black cards and half the cards being red cards. Down here, the jack, the queen, and the king, those are called the face cards. A common question is an ace a face card? And no, an ace is not going to be considered a face card. The jack has a face on it, the queen has a face on it, and the king has a face on it. Okay, and jokers are not part of a standard 52 card deck. So here's the notation we use, the probability of an 8. What's the probability from the 52 cards from getting an 8? Well, like we said, there are 4 aces, or really like 4 1s. There are 4 2s, there's 4 3s, all the way up to 4 8s. So your favorable out of the possible there are 4 favorable cards that are 8s. There's an 8 of clubs, there's an 8 of diamonds, there's an 8 of hearts, and an 8 of spades. Out of the total amount of cards, there are 52. So we can reduce that. We could divide both of them by 4. Or you may just want to cut 4 in half, cut 52 in half, so you get 2 over 26, cut 2 in half, cut 26 in half. Out of each group of 13, there is one of the cards that is an 8. And we can use our calculator, 1 divided by 13, or 4 divided by 52. You'll get the same decimal.
Would you prefer for us to reduce?
Would definitely prefer to have the fraction answer and reduce whenever possible. All right. Sometimes the numbers are just so big and crazy, but especially with the cards, you'll get used to how to reduce these. How about the red king? What's the probability of a red king?
2 over 52.
So there are 2 red kings, the king of diamonds and the king of hearts. There's 2 favorable cards over the 52 cards possible. So that's 1 out of 26. So 1 out of 26 is going to be the same thing as 2 out of 52. So that's 0.038. So that's like a 3.8% chance. Over here, we talked about the probability of an 8. Now, if the probability of an 8 is 1 out of 13, a little bit less than 8%, is the probability of a king the same thing?
Can you say that one more time?
Is the probability of a king easier or
It's the same.
harder, more likely or less likely than the probability of an 8?
Less likely.
Because there are 4 kings,
And then 4 8s.
it's just the same probability,
No, he said
regardless of the type of card or value that you're looking for. The probability of any card is the same. So it's not any easier to get a 2 than it is to get a 10. All right, some of these say solo, so you could be working on your own. The first thing I'd encourage you to do is just try to understand the question. The main thing is people are just looking for numbers and answers. Try to understand the question. You're looking for probability. You're looking for favorable over possible. So if you're looking for a red marble, you know that there are 6 red marbles and there are 10 possible marbles. And those can be reduced. Take half a 6, take half a 10. And the probability would be 0.6 or 3 over 5. Okay, you're going to roll a 6-sided die 300 times. This is starting to sound like experimental probability, but you're going to roll it 300 times. Based on theoretical probability, how many times would you expect to roll a 2? How often should you roll a 2? Well, if the probability of a 2 is 1 favorable side out of the 6 possible, the number of 2s you're going to get in 300 is going to be 50. So you're going to get it 50 times. Now, we know you may not exactly get it 50 times, right? If you actually rolled it 300 times, you may not get every number 50 times exactly. That's where experimental probability comes in, and we'll talk more about that tomorrow. What's the probability? No, what's the number of ways? How many times would you get a prime number?
So what's a prime number?
A prime number is going to be the numbers 2, 3, and 5. Those are the numbers that 1 and itself are the only things that go into it. So that's why we don't use 1 as a prime number, because 1 is part of that definition. So 2, 3, and 5. So the probability of it, you could say 2, 3, 5, or you could say probability of a prime. That's going to be 3 out of 6, which is 1/2. So you should get that out of 300 rolls 150 times. Now notice how we added. There were 3 different items here. So there's a probability of 1 out of 6, and 1 out of 6, and 1 out of 6, which gives us 3 out of 6 total. When we have or, we're happy with a 2 or a 3 or a 5. That's an adding process that we'll learn more about in the future. We want a 3 or a 4. So we're happy with 2 different outcomes out of the 6 possible. So that is 1/3. And the number of times you're going to get a 3 or a 4 is going to be close to 100 times. Now that would also be the number of times you'd get a 2 or a 5, or a 5 or a 6, or a 1 and a 4. Any of the 2 numbers would mathematically come out to this many times. Has nothing to do with the specific number. Okay, last one. This is solo. So go ahead, read the question. At home, I'd encourage you to pause the video, work this one out, and then I'll work it out with you. So we have a 14-sided die with the numbers 1 through 14 on it. We're going to roll the die 1 time. What's the probability of rolling an odd number or the number 6? So you're happy with all the different ways you can be odd, which is the number 1, 3, 5. You're happy with the number 6. The other odd numbers, 7, 9, 11, 13. And there are 14 numbers that are possible. So that comes out to be 8 out of 14, which can be reduced. Half of 8 is 4. Half of 14 is 7. And if you like the decimal version, that would be approximately 0.571, which would make sense because over 50% of the numbers are being listed as being favorable. All the odds would be exactly 50% of the numbers, and then you have the extra 6, so that's going to be the 8th number. There we have it. Experimental probability tomorrow.